Good morning. Welcome to the lecture series on digital electronics. 18 EC 302C. In today's lecture, we will continue the topic, the leftover topic, that is using Karnaugh map to simplify Boolean expression in SOP form. So we have seen how to simplify Boolean expression of 3 variables using Karnaugh maps, and we have introduced a 4 variable Karnaugh map also, and we'll take a few examples of simplifying function of 4 variables using Karnaugh map. And then next we proceed to look at how to simplify Boolean expression in product of sums form using kmap. So first we'll look at some of the examples of simplifying a 4 variable Boolean expression using Karnaugh map. So we'll take the first example. Simplify the Boolean expression where the Boolean expression f equals m1 plus m5 plus m10 m11 plus m12 plus m13 m15. So the expression can be given either as product terms directly, or it can be directly given as sum of min terms. So this is a short way of representing those min terms. So now the function is expressed so in the simplification procedure. The first step is to construct a 4 variable kmap, and you can see that the highest min term is 15. So that means it's a 4 variable function. So we need to construct a 4 variable kmap, and four variable 16 cell kmap is constructed, and here you can see that we can assume any names for the variables. So here I'll assume a, b, c, d, and instead can assign values to the rows and columns. So for rows, a bar, b bar, that is 0 0. Next it is a bar, b, and a, b, and a, b bar. Similarly, c bar, d bar, c, d, c bar, d, c, d, and c, d bar. Now you have to enter the min terms in the kmap. So m1 you can easily find out that is 0 0 0 1. So this row, this column. So m1, m5 means 0 1 0 1. So this is the cell corresponding to M5. Next M10. M10 means 10 should be expressed in binary, 4-bit binary. Then it becomes 10 10 10 10. This is a cell corresponding to M10. M11 10 11. 11 must be expressed in 4-bit binary, 1011. That is this cell 1011. It is this cell. Next M12. M12 is 1110. 12 expressed in binary is 1110. So 1110. So this is the cell. So M12, it is 1100. It is not this. It is 1100. Similarly M13. So 1101. 13 means 1101. So this is the cell corresponding to M13. And M15. So 1111. 15 equals 1111 binary. This is the cell corresponding to M15. So we have entered all the minterms in kmap. So we have 7 minterms: 1 2 3 4 5 6 7. Now what you have to do is you have to start looking at the isolated ones. That means the ones for which there is no adjacent cell containing another one. So there are no such ones here, because for every one there is always an adjacent one. So next you have to look at for the ones which are adjacent to only one other one, and try to form a group such that the group is found with maximum number of ones. So we have such one here. So this is the one which is adjacent to only this one, and when you want to form a group to include this one, so there are 3 ones, but you cannot form a group of 3, so you can form only group of these 2 ones. So by that, when you form group of these 2 ones, it is a bar b bar, this minterm is a bar b bar c bar d, combined with this minterm is a bar b c bar d. The minterm results is the variables which are not changing is a bar and c bar d. So it is a bar c bar d is the resulting is the term that is generated from this loop. Similarly, we have finished one loop. Next you have to find out more ones which are adjacent to only one other one. And here you can see this is the one that corresponds to the cell containing 1 which is adjacent to only one other one. Here also you look at try to form a group with maximum number of ones, which includes this. There are 3 ones, but you cannot form a group of 3, so you have to form a group of 2. So this is the group of 2, and you can see the min terms corresponding to this is A, B, C bar, D bar. Corresponding to this is A, B, C bar, D, which results in the product term which eliminates the variable which is changing, that is D. The result is A, B, C bar. Next, look at what are the other cells which contains ones which are adjacent to only one other one. You cannot select this because it is adjacent to this one and this one. You cannot select this because it is adjacent to this one and this one. But you can see that this cell containing 1 is adjacent to only this one, and here you can form a pair of 2 only, so form a pair of 2. It results in a product term. Min term corresponding to this is A, B bar, C, D, plus corresponding to this is A, B bar, C, D bar. The variable that is changing is D, so D get eliminated. Result is A, B bar, C. So look at the kmap for any leftover ones which are not yet grouped or not yet looped. So this is the only one which is not yet looped, but there is a possibility for forming the loop to include this one in loop along with the already looped ones, such that it can form a pair. So it can be either looped with this one or this one. Since we cannot form a pair of 4 by including this one, we can only form a pair of 2, a loop of 2. So we can either form a loop of these 2 minterms or these 2 minterms. So it is your wish to form loop of the choice. So I try to form the loop this way, and you can see that so the minterm corresponding to this is A, B, C bar D, plus corresponding to this is A, B, C, D. So the variable that is changing is C, it will get eliminated, and you can see that we can no more, we are not left with any more ones which are not yet looped. So there is no requirement of forming any further loops. So what you have to do as final step is form the OR sum of all the products that are generated. It is A bar, C bar, D plus A, B, C bar plus A, B bar, C plus A, B, D is the simplified expression for the given Boolean expression. So this is how we simplify the Boolean expression of 4 variables expressed in standard sum of products form. Next we look at More examples. Second example, we get to simplify the function f of a b c d, Boolean expression of function of the four variables, so which is expressed as the sum of minterms 0, 1, 2, 4, 5, 8 and 10. So this is another way of writing function as the sum of minterms. Small m indicates minterm, sigma indicates summum, and what are the decimal equivalent for minterms is 0, 1, 2, 4, 5, 8, 10. The summation of the 7 minterms. So since function is already expressed in sum of minterms, we can go for directly constructing the kmap of 4 variables. The row variables are, so here we'll be assigning only values such that it will be easy to enter the minterms as they are given, as their decimal equivalent numbers are given. So for CD, for columns also it is 0, 0, CD value is 0, 0, 0, 1, 1, 1, and it is 1, 0. So first thing is, first minterm is 0, that is equivalent to 4-bit binary is 0, 0, 0, 0. So this is the cell corresponding to this, and 1, 0, 0, 0, 1. So this is it. So 2, 0, 0, 1, 0. So this is the cell. And 4, 0, 1, 0, 0, 0, 1, 0, 0. So this is the cell. And 5, 0, 1, 0, 1. So this is the cell. And 8, it means 1, 0, 0, 0. So this is the cell. And 10, so 1, 0, 1, 0. So this is the cell corresponding to minterm M10. And now you can see, start applying the steps of the simplification process. So first you have to look at the isolated ones which are not adjacent to any other one. So by just looking at the kmap, you may think that these are the 3 isolated ones. 1, 2, and 3. These are the 3 isolated ones. But they are not actually, because the minterm corresponding to this is A, B bar, C bar, D bar. And the minterm corresponding to this is A bar, B bar, C bar, D bar. There is only one variable change, so these two minterms are adjacent. and also similarly these two minterms are adjacent, and you can also see that these two minterms are adjacent. Similarly these two minterms are adjacent, and I can say the minterms 1 2 3 4, that is the four minterms at the four corners of the four variable kmap are adjacent. So these are not the isolated ones. So we don't have any isolated ones. Next we look at the cells containing ones which are adjacent to only one other one. So we cannot consider this as the cell containing one which is adjacent to only one other one, because it is adjacent to this and it is also adjacent to this. And similarly all the four, and you can see this also, it is adjacent to this and adjacent to this. So there are no ones of such case also. So next what we have to do, next we have to look at the possibility of forming a group of all 16 ones. So if there are 16 ones entered into the kmap, you have to see the possibility there are no 16 ones. So next you have to look at the possibility of forming a group of 8 ones. So there are group of 4 ones here, but there are no group of possibility of forming group of 8 ones. So all 8 must be adjacent to each other to form a group. So group of 8 ones is not possible. So next we will look at forming group of 4 ones, and here you can easily see that these are the 4 minterms or 4 cells containing ones which can be grouped. So we will form a group of 4 ones here, and when I form a group of 4 ones, what are the minterms I form? It is a bar, b bar, c bar, d bar plus a bar, b bar, c bar, d plus a bar, b, c bar, d bar plus a bar, b, c bar, d bar. So what is the term generated by this loop? When you see over this entire loop of 4 ones, what are the variables that are changing, that you illuminate. So b is changing from 0 to 1, but a remains at 0. So it is written as a bar in the product. Since b is changing, b is eliminated, and go to the columns. C remains at 0, so it is written as C bar. D changes from 0 to 1, so it will get eliminated. So the product term that represents generated by this loop is A bar dot C bar. And after forming this group, you can see that there are 3 ones left. And we cannot form a group of 3, but if we include this one, the cell containing 1, along with this one, you can form a group of 4, as these 4 ones are adjacent to each other. So you can form a group of 4. So this is another group of 4. And what are the minterms? No. A bar, B bar, C bar, D bar, and A bar, B bar, C, D bar plus A, B bar, C bar, D bar this A B bar C B bar. So what is the term that is generated by this loop? You can see that over this entire loop of 4 ones, A is changing from 0 to 1. So B remains at 0. So the variable appears its complement form in the resulting product, and you can see observe the CD variables. C is changing from 0 to 1, so it will get eliminated, and D remains at 0, so it appears in its complemented form. So this is the B bar D bar is the equivalent and the term generated by this group of 4 ones. So there are no more ones left which are to be grouped. So final expression, simplified expression, is the sum of the products generated. Next we look at how to simplify the Boolean expression if it is given in product of sums form. So previously we have observed that the procedure is the general procedure for simplification using Karnaugh map. When the expression is expressed in SOP form is we construct kmap and place ones in those squares corresponding to the min terms present in the given function. And after that we'll form loops and we'll write we'll express the function as the sum of product terms generated by the loops. So here when you want to simplify the Boolean expression in POS form using Karnaugh's map, the only thing that changes is here the function is expressed as the sum of standard product of sums form. That is, the function is expressed in standard sums. Function contains the standard sums, and you can see that the procedure for simplification will outline the procedure along with an example by taking while going through the example we'll outline the procedure. So the example here we'll take is, so use Karnaugh map to simplify the following expression in standard POS form. The expression is f equals a plus b plus c, a plus dot a plus b plus c bar dot a plus b bar plus c dot a plus b bar plus c bar dot a bar plus b bar plus c. And you see that this function expressed as the product of standard sums, or the function is expressed as the product of max terms. You can see all the term contains all the three variables, so it is expressed as the product of max terms. So in the procedure that we need to follow, first you check that the function is present in standard product of sums from or not. So if not, you convert that to standard product of sums from. So once it is in standard product of sums from, so first is check for the function to be expressed in standard POS form. So once it is present in standard POS form, so that means you find only max terms in the expression. So next construct kmap. Construct kmap. The kmap will be constructed like we constructed previously. Construct kmap, and but here the change is place zeros in those squares and cells corresponding to the max terms. Present in the expression. So this is the only change. We construct kmap as usual, but instead of placing ones or entering ones, we'll enter or will place zeros in those squares corresponding to max terms. So this is the only change, and after that other steps are we have to form or we have to group zeros. So the third step is group zeros. And grouping rules are same. That means we have to look for first isolated zeros. Next we have to look for the zeros which are adjacent to only one other zero, and next we have to look for group of 16 zeros, and if not group of 8 zeros, if not group of 4 zeros, if not group of 2 zeros, and finally we have to form and product of all sum terms that are generated by each loop. So this is the procedure. So we will start applying this procedure to the given function, and we see that the function is of 3 variables. So we will construct the kmap of 3 variables. Variables are A, B, C. As usual, this row represented by A bar, this by A, and this by B bar, C bar, B bar, C, BC, and this is BC bar. This is how we construct the map when we want to simplify expression in SOP form. But to construct kmap for the expression in POS form, so this is in SOP for SOP form. So for POS form, how the kmap is constructed in somewhat different. Means two, three variables A, B, C. So you here see that the A takes value 0 for this row and 1 for this row, and BC take the values 0 0 for this, 0 1 for this, 1 1 for this, 1 0 for this. So both are same actually, but you cannot write the product terms in this way because it gives you the terms as product terms. So you write draw the key map in this way by putting values for the variables. So now we'll start entering the max terms given in the expression. It is A plus B plus C, and you can see that while we are writing max terms, the variable appears in its original form when its value is 0. So that is, when value of A is 0, it appears in its original form when we write max terms, that we already learned. So this value of A is 0 and value of B is 0, value of C is 0 here, because all of them are in original form. Similarly, this one 0 0 1, C is in complement form, and here it is 0 1 0 0 1 1, this 1 1 0. So now start entering this product term to the key map, and so the first product term is 0 0 0 0. So here what you have to enter is, you have to enter zeros. Why? Because these are the product terms and these are the sum terms or max terms. Next one is 0 0 1 0 0 1. So this is the max term 0 0 1. Next max term is 0 1 0. So 0 1 0. So this is the max term. Next is, this is 0 1 1. So 0 1 1. So this is the max term. The last one is 1 1 0. So 1 1 0. So this is the max term. We reduce the only change. So here, instead of writing the variables, we have written values assigned for each row and column for those variables 0 1. So this is similar, but here when we are writing entering the max terms, you have to be careful that when in max terms the variable present in its original form, its value is 0. When it is present in its complement form, its value is 1. So we'll write first the values represented by the variables, and by that values we'll enter zeros into the corresponding cells of the max terms. So we have entered the function expressed in max terms into the kmap, and now what we have to do, we have to group the zeros, and for grouping zeros we have to follow the same procedure as we did for grouping ones. First find out the isolated zeros, that is the zero which is not adjacent to any other 0. So there is no such 0. Next go for the zeros which is adjacent to only one other 0. You can see that this is the cell containing the 0 which is adjacent to only this one. So what you have to do is you form a group of these two zeros. And so what is the product term represented by this? It is a, its value is 0, so it is a, and this is a plus b bar plus c. This is the product term, this is the sum term, and the sum term represented by this is a bar plus b bar plus c, and this results in sum term which eliminates the variable that is changing between these two zeros, that is a is changing, so a will get eliminated. The resulting sum term is b bar plus c. And after forming a group of these two zeros, you can see that 3 more zeros are left, and here you can see that you find a 0 which is adjacent to only one other 0 which is not yet grouped. So here this is the 0 which is adjacent to only this 0, but you can see that you can form a pair of 2, but instead if you include the already paired 0, this 0, you can form a group of 4 zeros this way. So what is, so instead of forming a pair, if you form a pair of group of 4, you will be able to reduce the number of variables drastically. So we will be forming group of 4 zeros here, and you can see the product term, max term, sum term corresponding to this 0 is a plus b plus c, and this one is a plus b plus c bar, and this is a plus b bar plus c bar, and this is a plus b bar plus c. It results in the sum term. You can directly see that. So what remains constant is, for these 4 zeros, the variable a value at 0 remains unchanged. So it is written as, since value is 0, it will be written in its original form, plus any other variable which is not changing for all these 4 zeros. You see b is changing from 0 to 1, and c is also changing from 0 to 1, so there is no other variable, so the sum term is only a. And finally, by step 4, by the last, so we have finished forming group of all zeros. Finally, what you have to do, our expression, the final simplified expression for f is the product of all the sum terms that are generated by the loops. So first term generated by the loop is b bar plus c, and second term, sum term generated by the loop is a. So we have to take product of the sums generated, and this will be the simplified expression. So what we did, actually, we'll review this. So we have taken example where f is expressed in product of sums form, and usually it is a 3 variable, so we constructed a 3 variable kmap. So instead of writing the variable names, so we have written the values assigned for each row. This is similar to the normal kmap. So before entering the max terms in kmap, we'll write its their equivalent value. A plus b plus c means the value is, so this is a max term, so the variable when it appears in original form its value is 0, and when it appears in complement form its value is 1. So by following this we will write the binary represented by each max term. So this represents 0 0 0. So go to the kmap and enter 0 into the cell corresponding to the values 0 0 0. So this is the cell, enter 0. Similarly, enter zeros into all the cells corresponding to the max terms that are given in the given expression. So once you enter the zeros, so you have to start forming groups of zeros by following the similar rules as we grouped ones. And once you finish, so each group will generate a sum term. Each group here, group of 0 will generate a sum term. And finally, to get the final expression, you have to take AND product of all the sum terms and write this as an expression, and that will be the simplified expression of the given Boolean expression. So we'll take one more example. Example number 2 for the product of sums form expression simplification using kmap. So use kmap to simplify the function f expressed as the product of sums as b plus c plus d multiplied a plus b plus c bar plus d and a bar plus b bar plus a bar plus b plus c plus d bar a plus b bar plus c plus d and a bar plus b bar plus c plus d. This expression, if you observe the sum terms, except this sum term, all the sum terms are actually max terms. They contain all the 4 variables, but this contains only 3 variables. So first, that means this function is not exactly in the sum of max product of max terms form. So first convert the function into product of max terms. So no need to do any modification for these remaining the last 4 terms, but only we have to manipulate this term to make it contain all the 4 variables. So what we have to do is we have to look for what is the missing variable for this term. So the missing variable for this term is a. So what we have to do is we have to add the missing variable multiplied with its complement for this term. So this will not change its value as a dot a bar is 0, 0 plus the something is the something itself. So this will not change, and the remaining products will remain as is. And when you expand this, you see that by applying Boolean postulates, so this term becomes a plus b plus c plus d. The one more term we get is a bar plus b plus c plus d, and the remaining terms will write as is. a plus b plus c bar plus d bar plus b plus d bar. Next a plus b bar plus c plus d a bar plus b bar plus c plus d. So we'll construct a k-map, and before constructing k-map, we'll write the equivalent binary values for all these sum terms. So since when it is expressed in original form, its value is 0, so it is 0 0 0 0, and this is 1 0 0 0, this is 0 0 1 0, this is 1 0 0 1, this is 0 1 0 0, this is 1 1 0 0. So now we'll start constructing kmap. So this is a 4 variable kmap. So 4 variable kmap a b c d, and we'll write values here 0 0 0 1 1 1 1 0, and here also we'll write values for a b variables 0 0 0 1 1 1 1 0. So now we'll start entering these max terms, and into the corresponding cell we'll enter a 0. So 0 0 0, so this is the first cell, we'll enter 0, and next is 1 0 0 0 1 0 0 0, so this is the one. Next 0 0 1 0 0 0 1 0, so this is the cell. Next 1 0 0 1, so 1 0 0 1, so this is the cell. Next 0 1 0 0 0 1 0 0, so this is the cell. Next 1 1 0 0 1 1 0 0, so this is the cell corresponding to the max term. So next we'll look at, so we'll start looping the ones, the zeros. So here again we'll follow the same method. We'll look at the zeros which are isolated, not adjacent to any other zeros. So we cannot say that this is isolated because this is adjacent to this, so we cannot say that. So we have to go for this next step, that is look for the zeros which are adjacent to only one other zero. So we can see that this is a 0 that is adjacent to only this 0. So you start forming a group of 2 zeros, and when you form a group of 2 zeros here, this results in the max term corresponding to this is a plus b plus c plus d, and a plus b plus c bar plus d. The max term corresponding to this is, you remove the variable which is changing, that is c. So max term, the sum term is a plus b plus d is the sum term. A plus b plus d is the sum term corresponding to this pair of 2 zeros. Next you see that are there any other zeros which are adjacent to only one other zero. So this is that 0 adjacent to only these zeros, so we form a pair of these two, and the max term corresponding to this is a plus b bar plus c bar plus, sorry, max term corresponding to this is a bar plus b plus c plus d. The next term corresponding to this is a bar plus b plus c plus d bar, and this loop generates a term, some term which generates the variable that is changing, that is d. So the term generated is a bar plus b plus c. So this is the term generated, and after forming this group you see that there are two more zeros left. You can form a pair of two, but that gives you more number of variables. Instead that if you include these two zeros also, you can form a group of four zeros. By that you can reduce the number of zeros. You can form a group of these four zeros, and you can see that the term generated by looping all these four zeros is the variables which are changing is a is changing from 0 to 1 and b is changing from 0 to 1. So for these four zeros, so a and b are eliminated, and the sum term, and for these four zeros c d remains at 0 0. So the sum term that is generated by this loop of four zeros is, since c value is 0, d value is 0, it is c plus d. So this is the sum term generated by this loop. And finally what we have to do is the function. So there are no more zeros left. So we finished with the looping, and the terms generated are these. So what we have to do is the function is the AND product of all these sum terms. This is the first sum term, and this is the second sum term, and this is the third sum term. So we'll take AND product, and this is the simplified expression of the original expression that is given. So this explains how to simplify the Boolean expression in product of sums form using kmap.